Hey, what's up everybody? This is Dan from Abbott University. And in this video I want to go over how to draw the unit circle. I find that with a lot of my students who are taking trig slash pre-calc, this can be an early hurdle that you need to get over because a lot of these subsequent quizzes and tests that you're going to have to take feature knowledge of the unit circle, and it's really good to memorize how to draw it. That way, the first thing that you do during a quiz or a test is draw the unit circle on scrap paper, because from that point forward, you can then use the unit circle that you drew as a reference for all of the problems. And if you don't know what that means, you definitely will as you take your trigonometry class. I'm going to present to you a way that was shown to me by my trigonometry teacher back in the day, and it's been years and I still remember exactly how to do it. So anyway, the first step is to shrink this stuff down. Hold on a second. First step is to draw the x and y coordinate plane. And I'm going to just draw that in black. And then what you're going to want to do is subdivide that thusly. So it's almost like a pizza pie that you're dividing into 8 slices. So I like to do things systematically. I like to approach math problems in general in a systematic way where like for example, right now all we're doing is drawing the lines. We're not worrying about coordinates right now. We're not worrying about angle measurements right now. We're just simply getting the line drawing aspect over with. And the next group of lines that you're going to want to draw, you have to be a little bit careful with this one. Well, first of all, let's get clear. I'm not drawing perfectly. This should all be intersecting perfectly at the origin. Obviously I didn't do that, but you guys get the idea. The next group of lines that you're going to want to draw, you have to be careful because it's kind of this narrow passage here where you're drawing from here and then through the origin and you're coming out here. So what you don't want to happen is some kind of mistake where you're drawing here and then you come out here by accident. Okay, so you do have to draw those initial few lines as straight as possible so that you don't make that mistake. So let's give it a shot though. Okay, we've got that one. And you got these. Alright, so that is a pretty big old mess. But good. Thankfully we can kind of zoom in and zoom out and all. So then what I like to do is write down the angle measures. Alright, so once again, approaching this systematically where we're focusing only on the angle measures now. And the first thing, really the only two things you need to know regarding the angle measure is that you need to remember that this here is 0, 2 pi, and this is pi. Okay, now I'm just going to write that down and I'll explain it in a second. So we have 0, 2 pi, and then we have pi. First of all, just as a reminder, you know, when I say pi, 2 pi, and pi, we're in radian measurements. Often when drawing the unit circle, we're referring to radian measurements. Up to this point, most students are used to measuring angles in degrees. However, radians is another very useful way to describe angle measurements. I'm not going to get into what radians are. I'm going to assume that the students watching this video know that. But what you do need to know is that 0 radians does indeed equal 0 degrees, and 180 degrees is pi radians. Okay, so if you can remember that, you're good to go. And of course, so this is pi radians, and another 180 degrees stacked on top of that would be 2 pi radians. So we could think of this first angle that starts here and then opens to nothing. I mean, it doesn't open at all, actually. That would be 0. But if we were imagining an angle that opens all the way around and then ends on itself, creating this huge, ridiculous angle. Well, that's what we know as 360 degrees, and in this case, it's 2 pi radians. Okay, so nonetheless, just remembering that this is 0, 2 pi, and this is pi right here. Now, here's the way I like to think about it. At this point, I move into this kind of counting method. And what I mean by that is, if this is pi, then halfway over that distance must be half of pi, right? So that, therefore, is pi over 2. Okay, pi over 2 right there. So here's where the counting thing begins. I say to myself, all right, well, this is pi over 2. Then this is 2 pi over 2. Then this is 3 pi over 2. Then this is 4 pi over 2. So I'm not going to do that again. I am going to do that again. 1 pi over 2. 2 pi over 2. Think about it. 2 pi over 2 reduces to just pi. Pause the video and think about it if you have to. And then this is 3 pi over 2. So I'm just going to write that. And then this is 4 pi over 2, also known as 2 pi. 4 pi over 2 would reduce to 2 pi. Okay? So that's how you do the counting method. Now, when I'm doing the counting method, you always want to count the original XY axis. And if you don't know what I mean by that, we'll see examples of that in the future. Okay, so we've made it this far. All right, we've got this, we've got this, we've got this. Now I like to focus on these red lines here. You know, the original red lines that I drew that would create like 8 slices of pizza, basically. And what I do there is I notice that, okay, well, if from here to here, if that's pi over 2, then that means that this is half of pi, right? Half of pi right here. And this is half of that distance. So this must be pi over 4. Okay, since this is half the distance of pi over 2, this has to be pi over 4, also known as 1/4 of pi. So then I do the counting method again, where it's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Now I'm going to say that again. That's 1 pi over 4, 2 pi over 4, which reduces to pi over 2, and then we have 3 pi over 4. Let's go ahead and write that. And then finally we have 4 pi over 4, which reduces to just pi. Alright, so once again, notice how when I did that counting thing, I did 1 pi over 4, and then I counted this black line. So once again, when you're doing the unit circle and you're using this counting methodology, you always want to count the black lines, always. Okay, so once again, 1 pi over 4, 2 pi over 4, 3 pi over 4. We have 4 pi over 4. Now guess what? This is going to be 5 pi over 4. And then we have 6 pi over 4, reducing. 7 pi over 4 right there. And then finally, 8 pi over 4. Okay, so once again, I want to just make it very clear that all we did in the beginning was put our 0, 2 pi here, and our pi here, and that gave us enough information to do this counting method all the way around so far. Okay, now here's the part where unfortunately you might have to just kind of memorize something. This right here is pi over 6. Now you could just simply remember that. Okay, I think most students usually don't have a problem just simply remembering that. However, let's say you were lost and you drew a blank and you couldn't remember that. Well, you could see that, you know, this right here is, once again, 1/2 of pi, also known as pi over 2. And these guys here represent like 1/3 of that entire angle. Alright, notice how this middle third, it looks bigger because the drawing's not drawn to scale. I didn't draw it perfectly, but these should all be equal thirds. of this whole angle here. And notice how this middle third, it encompasses the red line. Okay, so you can think of it that way. So okay, well that's great. If each of these guys are 1/3 of that amount, well we could also kind of replicate that situation over here. And that clearly results in a situation where you have 6 of these things. And therefore that means that this is 1/6 of pi. Okay, so that's the kind of long way of remembering it. But you could also simply memorize that this is pi over 6. Now what we're going to do here is the exact same counting method where it's, you could even start here, be like 0 pi over 6, 1 pi over 6, skipping this thing, 2 pi over 6 right there. I'm just going to write that for now. And remembering, do not forget to count the black line. That is 3 pi over 6, but we already have pi over 2, right? So 3 pi over 6 would reduce to pi over 2. So we have 3 pi over 6, then we have 4 pi over 6. I'm just going to go ahead and write that. Then we have 5 pi over 6. And then finally we have 6 pi over 6 right here. Let's just pause there. I want you to see that this 2 pi over 6 could immediately be rewritten as 1 pi over 3. Okay, so that is true of this. And this right here could be rewritten as 2 pi over 3. So what I'm going to do is actually backtrack and write that just to save room on the page. And this ended up being 2 pi over 3. But just remember that we got this stuff by doing the pi over 6 counting thing. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is still 5 pi over 6. And then of course we have the 6 pi over 6. Now what's this one? 7 pi over 6. And then we have 8 pi over 6. I'm going to reduce it right now. That's 4 pi over 3. But that was 8 pi over 6. So that makes this 9 pi over 6, which reduces to 3 pi over 2. Which makes this 10 pi over 6, which reduces to 5 pi over 3. But when you write that, just remember this was 10 pi over 6, and then this is 11 pi over 6. Alright, so once again, going all the way around, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and guess what? This is actually 12 pi over 6 corresponding with the 2 pi. Alright, so basically that is how to use this kind of counting method to write all the angles that are represented on the unit circle. Unfortunately, there's more to do there, because if you're indeed dealing with the unit circle, you are then therefore dealing with this circle that has a radius of 1 on the xy coordinate plane, and you're going to have these angles that are kind of represented here like we did, but then on top of that you're going to have these coordinates around here. Okay, and the coordinates represent like the points that fall on the unit circle. So that's this extra thing that you're going to have to do when you're working with the unit circle. So what I'm going to do is redraw that unit circle actually, because that unit circle is pretty ugly. So try to make it at least somewhat presentable here. And then we're going to label the point on the circle from there. Now what I'm about to do is something that is systematic once again. And what that is when I'm drawing the points, obviously we're used to drawing points where the coordinates are like this, where you have an x coordinate and a y coordinate, and then you have these parentheses, right, and then you have a comma, right, and then you have some value here and some value here. Well, I'm going to do that right now, actually, once again, working systematically through this unit circle, where, you just know that there's going to be this, so you go ahead and just draw it. You know what I mean? Like, I'm kind of a fan of any time, since math is so hard, or it can be so hard, anytime you can conserve mental energy and allow yourself to move into this kind of autopilot mode, I actually think that that's a good idea. Maybe some people would disagree. But right now, I don't have to think about anything. It's kind of cool. My brain is taking a vacation as I simply draw these things. And guess what? I'm going to have to draw them later anyway, so I might as well draw them now. So, just moving through this, obviously I'm going to have to be careful to remember that this one refers to this point, this one refers to this point, but I'm trusting myself to remember that. So you go ahead and just get this part over with. Then I'm going to do something else that's systematic, in that if you look at this first quadrant, isn't it true that both the x-coordinate and the y-coordinate are going to be positive? Yes, definitely. In the first quadrant, the x-coordinate and the y-coordinate are positive. That applies to these points here. Now, this should get, pardon me, this should get something too. Okay, so isn't it true that these are all positive? So you're going to want to represent that by not having any negatives there. However, when you analyze this second quadrant here, isn't it true that all the x values are negative? Okay, and that actually includes this one here. Okay, so all the x values here are negative where the y is positive. So what I'm going to do is I'm going to represent that by drawing a negative in front of the x values. Okay, now when I draw this negative, the left-hand part of that negative symbol is kind of touching the parenthesis. Alright, so once again, in a sense, moving on autopilot, where I'm just getting that part over with, because I already know that we're dealing with a negative there. Okay, now when you're analyzing the third quadrant, as some of you may be guessing already, both the x coordinate and the y coordinate are negative in the third quadrant. Okay, now that does not apply to this one. Okay, this is where it can get confusing, because this is going to end up being a y coordinate of 0, which is neither positive nor negative. But this whole idea of the x and the y being negative, it definitely applies to this point, this point, this point, these three in particular. Okay, so we're going to go ahead and represent that. So I'm going to do the first thing that I did, but now I'm going to do another negative that's kind of like right next to the comma. You see that? We have a negative here, and then another negative right next to the comma. We have a negative here, and then another negative right next to the comma. Now, this one happens to have a an x value of 0, so that's neither positive nor negative, so we're just going to leave that alone for now. However, when we focus on this fourth quadrant here, what's the deal there? Well, we're going to have a positive x value and a negative y value, right? So let's represent that. Now, this one right here, this 3 pi over 2, that corresponds with this coordinate. This 3 pi over 2 is going to be a 0 and then a negative y value. So we can go ahead and just write that negative there. As far as the other coordinates, we can have our negative only next to the comma, similarly. Okay. And we're going to just leave it at that for now. Okay, so we've actually come a long way. We're extremely close to deriving this entire unit circle. Okay, and actually at the end of the video, I'm going to do it in real time. I'm going to do it fast. So even though it seems fairly tedious, you'll be able to see like how quickly you can do this once you get the hang of it. Honestly, it's going to take less than like 3 minutes. Like as soon as your teacher hands your test or quiz out, you just bust out the unit circle on your scrap paper, and it takes like 2 seconds, and then you can use it. But anyway, the next mission of yours is to find out what these actual coordinates are. What are these points here? Okay. Now, here's the way to approach that. What you're going to do is you're going to make a chart that, in a sense, represents the activity in this first quadrant only. This first quadrant only. Okay? And here's what the chart could look like. The first chart would be a theta symbol, and underneath it you're going to have an X, and underneath it you're going to have a Y. And that's, in a sense, your first column. Okay? And you draw a line there. And then what you're doing is you're representing the following angles. You're representing the angle of 0 pi, pi over 6, pi over 4, pi over 3, and pi over 2. So that's what? 1, 2, 3, 4, 5 angles that are being represented. Since I know that I'm going to be dividing this into 5 columns, I'm just going to draw that middle column first. That's kind of a cool thing to do if you're dividing something like this into an odd number. Just draw the middle column first, and then we're going to draw these two guys here, and that should make it reasonably decent looking. Alright, so the first angle that we're representing is 0, and then we've got pi over 6, and then we've got pi over 4, and then we've got our pi over 3, and then finally we've got our pi over 2. Alright, and now we're going to have to use our knowledge of unit circles having a radius of 1. And what I mean by that is we should be able to understand that this coordinate here, this point on the unit circle where my red dot is, that corresponds with 0 degrees. That should be a coordinate of 1, 0. That is clearly an x value of 1, because here's the origin. You go over 1, which corresponds with an x value of 1, and it doesn't go up or down. It's on the x-axis, so therefore we're dealing with a y value of 0. So I say we just fill that in right now. So we've got 1, 0. Okay. Now similarly, up here, you should be able to use the exact same reasoning in that this is an x value of 0 and a y value of 1, okay, for this particular point here. Okay, similar reasoning. X value of 0, y value of 1. Okay. So let's represent that right now. When you're dealing with the angle of 0, what are the x and y coordinates? 1 and 0. When you're dealing with the angle measure of pi over 2, right here, what are the x and y coordinates? 0 and 1. Okay, so let's backtrack. We made the chart. Okay, we're dealing with 3 rows and ultimately 6 columns if we're going to have this kind of theta xy thing represented, right? So 3 rows, 6 columns. Okay, we filled in the angles, blah 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 blah, we got the x and y, and then the first thing we do is we tend to the angle of 0, and then we tend to the angle of pi over 2. Alright, now we're about to do something in autopilot again, which is always good news. what we're going to do in autopilot, I'll do this in blue just to kind of differentiate this section from the rest of the chart. Each of these are going to be fractions. So just draw the line, draw the line that would divide the numerator and the denominator. Okay, so that's really good news. You just draw the line. And then underneath, it's always going to be a 2. So let's just get that over with. Isn't that nice to know? Always going to be a 2. And now here's another thing that's really interesting and nice to know. The numerator is always going to be, at least for now, it's always going to be this radical symbol. So you just draw it. Okay? Now here's the cool part. When analyzing this row that corresponds with the x-coordinate, so this is an entire row that corresponds with the x-coordinate. You see how we go from 1 to 0? That represents this kind of decreasing action, right? We go from 1 to 0. That's like this decreasing action. So what you're going to write in this row is you're going to represent that decreasing action by writing 3, 2, 1. Okay? Decreasing action from 1 to 0, 3, 2, 1. Down here in this row that corresponds with the y-coordinate, you're going to have this increasing action from 0 to 1, right? That's clearly increasing. So obviously, as some of you would guess, we're going to go 1, 2, 3. Congratulations, you have just successfully made a chart that will make labeling all of these points ridiculously easy. Okay? Now I say let's go ahead and analyze it first before we fill this in. Okay, so what that means is when you're looking at the pi over 6, you're dealing with an x value of radical 3 over 2 and radical 1 over 2. Now a quick note on this radical 1 over 2. Isn't it true that radical 1 over 2 equals 1 over 2? Because the square root of 1 is just 1. So every time we see this radical 1 over 2, we're going to write in here 1 over 2. Now, for the sake of moving into autopilot, we just drew the radical symbol over all of them. I'm still a big fan of that because just do it. Because honestly, when you're doing the autopilot, you're not going to want to worry about which one of these is 1/2. You're just going to want to be like 3, 2, 1, and radical, radical, radical. You know what I mean? But when you actually put these coordinates into the graph, you might want to just represent this radical 1 over 2 as 1 over 2. Alright, so not a lot of room on my screen, so let's just kind of do the best we can with writing this all. Alright, so let's see here. We've got our pi over 6 right here and right here. So that's radical 3 over 2 and also 1/2. So I'll do that in this blue ink to correspond with the blue ink of the angle line. So radical 3 over 2 and we've got 1/2. Cool. And then looking at the next angle, we've got pi over 4. That's going to be radical 2 over 2, radical 2 over 2. Alright, so that's radical 2 over 2, radical 2 over 2 again. Alright, and then of course we have pi over 3, which is 1/2, right? We're dropping the radical for now. And then radical 3 over 2. So we've got 1/2 and radical 3 over 2. Awesome. Now here's the deal. I'm just going to shrink this down because believe it or not, we actually don't need it anymore, interestingly. I mean, when you're doing this on scrap paper, you'll still have access to it, which is fine. But for our purposes, we don't really need it anymore. because the good news is once you've cracked the code of the first quadrant, then you can use that to find everything else. All right, now what we're going to do is we're going to focus now on the second quadrant. Why not? When you do that, you want to treat this this x, or pardon me, the y-axis here as though it's a mirror. Imagine you have like some stuff over here and it's looking in the mirror and it's going to be perfectly reflected over here. Perfectly reflected over here. So what that means is this coordinate gets reflected with this coordinate. Okay, the perfect reflection of this coordinate across the mirror is this one. And here's the cool thing. You just write the same thing. So this 1/2 comma radical 3/2 goes here. All right. But as you can see, before I write this, we have the negative already in place. So all of that has already been taken care of, which is awesome. Okay. So we have 1/2 and radical 3/2. Because now I don't even have to bother worrying about the negative because it's already there. All I have to worry about at this stage is perfectly reflecting this angle with this angle. And I'm going to do it with this one too. Alright, so we got radical 2/2. We're going to have radical 2/2 over here. And once again, I understand that when I'm explaining it like this, it can seem extremely tedious because I'm explaining it. However, I'll demonstrate how quick it can be later. We've got radical 3/2 and 1/2. That's going to perfectly reflect over here. Good. So we've accomplished that. Now what we're going to do is we're going to treat this x-axis as though this is a mirror. Okay, and then we're going to perfectly reflect these guys across the mirror. Okay, and I'm realizing right now there is something that we could do right away as well before we do that mirror thing, and I apologize for this. Hopefully it doesn't cause confusion, but you know that we had 1, 0, we had 0, 1. Actually, we could do -1, 0 here now immediately, because that should be obvious, right? For the same reasons that this is 1, 0 and this is 0, 1. Well, this is going to be -1, 0. And in fact, let's get this over with too. This is going to be, what is it, 0, -1. All right. So I apologize if that causes confusion. That is something that maybe we could have done before, but you get the idea. All right, nonetheless, for now, we'll still treat this x-axis as though it's a mirror. And this thing, this guy, gets reflected perfectly with this guy. This thing gets reflected perfectly with this thing. And this one gets reflected perfectly with that one. So let's do it. Zoom in more, it gives me a little bit more room to write. We've got this radical 2/2 here. Alright, which I'm not going to zoom out again, but you get the idea. It's perfectly reflected. And this should be 1/2 radical 3/2. Not a lot of room to write that, but you get the idea. Again, you could have better handwriting than me. I'm using this thick stylus thing that doesn't always lend itself to accuracy. But you get the idea. And of course, notice the negatives are already in place, right? The negative signs are already in place. So we don't have to worry about that. And for this fourth quadrant, you have the option. You could either reflect all these by using the across the x-axis using the first quadrant, or you could reflect all these across the y-axis using the third quadrant. I say we do it that way, just to kind of show, to keep going with this circular motion in a sense, where this one's going to be perfectly reflected with that one, this one's going to be perfectly reflected with that one, and this one's going to be perfectly reflected with that one. Okay, so let's check it out. Right, that was a mistake, but whatever. Looking at these guys, we're looking at 1/2 radical 3/2, so that's going to be represented right there. This is going to be our radical 2 over 2. And then this one's going to be our radical 3 over 2, comma, 1/2. And guess what? You, my friend, are done. All right, so that's how you can derive the unit circle very quickly. All right, so wish me luck. Here I go. I'm going to see if I could draw this thing like real fast so you can see how useful it can be. Alright, so here I go. First thing I'm going to do is draw the XY coordinate plane. I'm going to draw these subdivisions here, and then these subdivisions here. Forgiving myself for any inaccuracy at the origin, keeping in mind that this origin, they're all perfectly intersecting. And then I'm going to represent 0 to pi, and then we've got pi. So if that's pi, then this has to be pi over 2. And then counting around, we have 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, and if this is 1/2 of 1 pi over 2, it is therefore pi over 4. If we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, good. Then I remember that this is pi over 6. I'm just going to write that. So we have 1 pi over 6, 2 pi over 6, also known as pi over 3. 3 pi over 6, we have 4 pi over 6 here, also known as 2 pi over 3. But it was 4 pi over 6, so then we're dealing with 5 pi over 6 here. Then we have our 6 pi over 6, and then we have our 7 pi over 6. 8 pi over 6, also known as 4 pi over 3. But it was 8 pi over 6, so this is 9 pi over 6, also known as 3 pi over 2. But that was 9 pi over 6, so we're dealing with 10 pi over 6, also known as 5 pi over 3. But it was 10 pi over 6, which means that this is 11 pi over 6. Cool. I also keep in mind that we're dealing with coordinates if you're dealing with the unit circle. So let's draw the circle. Now the coordinates are literally here, and here, and here, and here. But I'm going to, just for the sake of having a decently attractive graph, we're going to have the coordinates outside here. So I just know that it's going to be parentheses with commas, yeah? So let's get that over with. Sometimes in class you'll have your teacher will hand out a worksheet that has all this provided, and in which case that's pretty nice. But you won't always have that, necessarily. Alright, good. I just did all the parentheses and stuff. Now I'm going to go ahead and draw the negative symbols that I know exist. We're dealing with negative x values here. We're dealing with negative x and y values here. Actually, that's a mistake. That should not be a negative. I apologize for that. But we're dealing with a negative y value here in the fourth quadrant. Good. Alright, and before I move into the chart, I'm just going to go ahead and label things that should be relatively obvious. For example, this is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. So sorry for that being messy. Okay, now I'm going to bust out my charts where I know it's 3 rows and ultimately 6 columns. So we could draw that, divide this in half, and then divide each half into thirds, which would give us the 6 columns that we need. And then for the 3 rows, you just kind of draw this center row and that should do the trick. Now, if I remember correctly, this is going to be theta, and this is going to be x, and this is going to be y. We are dealing with an angle measure of 0, an angle measure of pi over 6, pi over 4, and pi over 3, and then finally pi over 2. This should be filled in immediately as 1, 0, and this should be filled in immediately as 0, 1. I then remember that I have fractions in all of these guys, so I'm just going to draw that right now, put a 2 underneath them. Bam, bam, bam. We get our radical symbols going. I see the decreasing situation here in the top row, so that's 3, 2, 1. I see the increasing situation here in the bottom row, so that's 1, 2, 3. That is a chart that will enable me to properly fill in these guys. I'm going to do it all in black just to save time. So we are dealing with, what is it, radical 3 over 2 and radical 1 over 2. So radical 3 over 2 and 1/2. We're dealing with radical 2 over 2, radical 2 over 2. And then here we're dealing with 1/2 radical 3 over 2. Good, I'm going to take this off to the side because honestly I don't need it anymore. And then over here I'm going to reflect across the y-axis. We have 1/2. We have radical 3 over 2. We have radical 2 over 2. Radical 2 over 2. We have radical 3 over 2. And 1/2. Good. I can reflect across the x-axis between the second and third quadrant, which results in me having radical 3 over 2 and 1/2, radical 2 over 2, radical 2 over 2. Also, we have our 1/2 radical 3 over 2. Again, sloppy, I know, but whatever, you get the idea. And then reflecting here, we have our corresponding with this thing. These guys correspond. So we're going to have 1/2 radical 3 over 2. Here we will have our radical 2 over 2, radical 2 over 2, and here we will have our radical 3 over 2, 1/2, which reflects across the y-axis from the third quadrant to the fourth. Alright, done. So, good luck. Obviously, you could press pause in this thing, you can review this thing, you can fast forward this thing, but this video should be a decent tool for you, especially in the beginning of your trig pre-calc class. Alright, so good luck everybody. AbbotU.com, visit it, and if you want tutoring, let me know. I do Skype. Take it easy. Alright, so here I go. Okay, and as I do it, I'm going to think out loud so you can see exactly what my thought process is. Alright, first thing, draw the XY coordinate plane. Alright, and then from there, I'm going to go ahead and further subdivide it into these pizza pie slices. Alright, forgiving myself for my lack of accuracy as I do it. And then I'm going to represent the fact that this is 0, 2 pi, and that this is pi. Okay, if this is 0 pi and this is pi, then this must be pi over 2. Okay, so that's 1 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Cool. If this is halfway, then we're dealing with, I'll do it in red, pi over 4. Okay, if that's 1 pi over 4, that's 2 pi over 4, then that's 3 pi over 4. Okay, and that would be 4 pi over 4, 5 pi over 4. And if that's 5 pi over 4, this is going to be 6 pi over 4, 7 pi over 4. And of course this would be 8 pi over 4. Now I just remember that this is pi over 6. So that's 1 pi over 6. This is 2 pi over 6, also known as pi over 3. This is 3 pi over 6. 4 pi over 6, also known as 2 pi over 3. But it was 4 pi over 6, which makes this 5 pi over 6. This right here is 6 pi over 6. Then we have 7 pi over 6. Oh, love it when that happens with this program. So that's 7 pi over 6. Then we have 7 pi over 6. We have 8 pi over 6, also known as 4 pi over 3. Then we have 9 pi over 6. 10 pi over 6, also known as 5 pi over 3. And then we have 11 pi over 6 over here. Great. Now, I'm also going to remember that we're dealing with coordinates as well.